Alright, so we should be live now. YouTube, I'm just waiting for YouTube to confirm that. Okay, YouTube says we are live now. So, let me very quickly go to Twitter and announce that. There we go. Okay, so on the agenda today is the new V2 PCB. I'm actually going to turn my music down slightly because this is a bit too loud for my liking. Where's the sound gone? No, I'll just use shortcuts then. Okay, there we go. Hopefully you guys can still hear me. Just let me know if you guys can't or whatever, and I'll adjust it in chat. Just type in chat if you have any problems with the stream. But this is the new PCB I have. Actually, let me quickly switch over to just purely the microscope. I've adjusted the microscope angles so that hopefully the glare from the light isn't so prominent. So it should be a bit easier for us to work on the PCB. And today, my task is to recreate a V2 of the PCB. So on the right of me, I've got my soldering iron and all the parts. I know you can't see this, but I'm just explaining my setup right now. And on the right of me, I have my oscilloscope, my trusty oscilloscope, and well, my soldering gear. So I suppose we start with the USB port. Actually, I'm thinking, no. First of all, I want to do the hardest chip here, which is U14. Since I have zero experience with QNF soldering. Whatever package this is, I think it's I think it's called QNF. For this SMD stuff, I think. By the way, if anyone's watching, can someone just type something random into chat just so I know that my view hasn't stopped refreshing? Because sometimes YouTube Studio seems to do that to me, whereby it chat might be typing, but I don't see any messages come up. So if someone could just type something really random into chat, that would be really nice, just so I know that I can see what you guys are writing. Oh yes, hello there. Sec. Okay. Okay, so I'm going to. Where's my flux? Oop, drop my syringe tip. Let's go ahead and clean that. Clean my tip. Oh, this flux smells very nice compared to the stuff I was using last week, but then again, I shouldn't probably be sniffing flux. Trying to get this QNF package out, and it's actually proving to be difficult to remove it from its packaging, so I'm just going to bend my tweezers a bit. There we go. Getting a bit more flux, I presume, should also help. Okay. Now let's just do the top and bottom sides. Ah! This PCB is becoming very finicky to move around. But I think I'm getting the hang of it. Okay, where are my Q-tips and alcohol? I want to clean that up, just to check if all the contacts have actually been made on this. Okay, I'm gonna quickly see if I can zoom in on that chip, just to check that it has indeed made contact. I think that's okay. Okay, so I think that IC is okay now. I'm just gonna quickly tidy up this little spot around here. Oh, I've made that worse. There we go. Okay, now I think I'll do these 1, 2, 3, 4 100 nanofarad capacitors. Except where did they go? They went here. 100 nanofarad. Slide 4 here. Okay, there we go. So we got 1, 2, 3, 4. Okay, so I think I'm going to do all 4 of these at the same time, just to make things a bit easier for me. So I'm going to tin all the pads together. Oh, that one didn't go well, and I'm also not in focus on the camera view. That'll do for now. Two. Come on. 3. Oh, where is it on my viewfinder? There it is. By the way, here's a question for chat. Can anyone recommend on Amazon some like good pair of tweezers for SMD assembly? Because I'm struggling to use these ones. Hang on a minute. Oh, I've done the wrong leg on this one. Whoops. It should be done by both sides now. Okay, I think that's good enough. Yeah, that should be okay. So let's do the USB socket now. PMS and the... Where is the socket I need? Where are my USB plugs gone? Actually, before I do that, I'll do this 3.3 volt LiDo here. I'll get rid of that. Although, here's my USB sockets. Actually, we can do the USB sockets now, I think. So, this is a high-tech USB-C connector. No longer using micro USB as suggested by a couple of mates of mine. I should switch to USB Type-C, so we are doing that. So I believe with these you solder the legs down first and then you solder all the electrical connectors. There we go, that's easier for everyone to see. Can you rip this off the board? There we go. Now, what I need to avoid happening is for the solder to wick its way up the legs of the USB-C port and into the plug itself. This happened last time we tried doing this. You were lingering too much smoothly on a single tip component contact. You'll rip the pad out due to the heat or damage the component. I mean, I've set my soldering iron to a measly 300 degrees Celsius. It's not too hot. Which is kind of like also just barely the hottest that the solder will melt. But yeah, I'll take that advice on. Thank you. Oh, that's not working. I should straighten my solder out. Thank you, by the way. Okay, there we go. Here's one down. 2 down, so I'll just quickly do the legs now. There we go, I think that's done. Yeah, I think we're good with the legs there. Oh, need to get more solder, 1 second. Move you into view. Okay. Right, so I feel like I should be able to plug this connector in now. Hey, that goes in perfectly. And also, if I plug this into my laptop, it shouldn't tell me that there's an error about power. Okay. Ooh, what's happened there? You know what? I'm an idiot, and I soldered this the wrong way. Oh dear. Well, I guess that released the magic smoke. It got hot enough to melt the flux around it. Okay. I don't know, is it worth me starting with a new PCB at this point, because we've only gotten this far, or should I just somehow find a way to rip this thing off the board, because I don't have any hot air on me? I mean, I'll try taking this out. I mean, it's just a few capacitors on the board, so in theory it shouldn't release the magic smoke. I mean, it shouldn't affect the PCB's operation, except, yeah, taking this out is going to be painful. I think I have some solder wick, but I don't know if that's going to do what I need it to do. Yeah, this is going to be a lot harder than I thought it would be to remove this guy from the board. You'll have a hard time removing it. Use solder wick and apply flux. You will damage your PCB. You'll rip the pads off the board. Okay, fine. Well, you know what? I've got 5 PCBs, so we just throw that one on the floor and we start again. Here we go then. So, this one, and this time we shall make sure that I get my orientation correct. The thing is, it looked correct to me. I don't know why. I must have jogged it before I then came back to solder it. That's really strange. I could have sworn it was perfectly aligned, and then no, I've flipped it by 90 degrees somehow without realizing it. Whoops. Hey ho, we live and learn. There are my caps. Where are my... Oh, where are those chips gone now? Oh, I'm gonna have to find them. Okay, it's none of those. C connectors, that's you guys, so I'll just quickly pop you in there so I know. I've got my caps here. Where did the transceiver chips go? 1 second, I must have dropped them on the floor without realising it. Or put them somewhere that I don't recall. That's really strange. Ah, here we are. CP2104. Okay, so we have 2 left, and I have 2 PCBs to assemble. One maybe later on, but this means that both of these have to go perfectly, or else I'm in trouble. That previous mistake was my one-time big mess up that I'm allowed, and then after that I have to get everything perfect, which is easier said than done when you're like a complete noob at soldering. There you go. Can never have enough flux, right? So here he is here. Okay, so the dot is on this side. 1 sec, let me see if I can free him. There you go. So the dot is on this side, which has to align with this dot over here. I think I actually managed to nail that first time. Look how perfect that looks. I mean, definitely at some point I'm going to see if JLC PCB does an SMD assembly service, so that, I mean, yeah, once I've got these into like production state, then I will go about automating the assembly process, because this is way too painful to hand assemble. For me, at least. I mean, for some of you guys on stream, you might just think this is really easy. But yeah, I'm new to soldering. Okay, time to quickly clean that off. Actually, I had a paintbrush here. 1 sec. I had a paintbrush I can fill with alcohol to get under all those little puny pads. 1 second. Let me get that paintbrush. Ah, here it is. You should get a hot air station. I can recommend buying one of the cheap Chinese ones. I mean, yeah, sure. That's a good point, actually. I could go ahead and do that. I am proud of soldering that IC. That looks really nice. I mean, what, this is my second time ever soldering a QNF chip, and yet it's actually come out surprisingly well. Yay, I'm learning. Thank you. Yeah, okay. So hopefully now this won't release the magic blue smoke, because that's definitely in the right orientation. You can see the dot here and the dot here on the PCB. And if I quickly go over to my combined view, you can see that more prominently here. The dot is definitely this corner here. Okay, so caps. Let's put them on now. Stick to the damn pad, will you? There we go. Also invest in low temperature melting solder. I mean, this melts at 300, is that not low enough? But then the thing is as well, because this is going in a car, I think high temperature solder is better for this application of components than low temp solder. Get my 4 caps out. Actually, I can realign you just a tiny bit. There we go. Oh, need to realign this one. Okay, I think I can just very quickly clean that up though. There we go, clean. I'll do a second round of flux in just a second. Okay, that's... Oh, you guys can't see that. I'm so sorry. Literally just looked up at the stream view. I was like, oh wait, you can't see that bit. Did you consider testing design on breadboard first before you ordered PCBs on every fault? No, I haven't, because all these components I want are SMD, which is really frustrating. So basically, the only way to test is for me to make SMD components. So yeah, a bit annoying. I mean, hey ho, look, I'm getting there. I think, fingers crossed, I want this to be the last, like, actual huge issues revision, or maybe this one's perfect. Like, I don't know. I mean, ideally I'd want this one to be perfect, but we can only dream. You think about it, right, so companies like Siemens, who makes the controller for this car, the stock one, they probably have like thousands upon thousands of hours put into designing it. And there's also a whole team of fully qualified electrical engineers doing this. I'm just a nobody trying to make this. So, of course, it's never going to be as quick in terms of a design process. But I can try, which is the main bit. Also, I might want to consider changing this tip to a thinner one. I don't know if a thinner one is necessary, though. Right, can you guys see that resistor I'm soldering? Capacitor? No, you cannot, so I shall move the PCB further down. Okay. Oh, sorry, I forgot to move it again. Ah! No, don't do that. Why did it do that? Why did it move the whole component when I heated that one up? Why is it now not heating its... There we go. Up you come. I'm just going to change you out for a new one. And not try ripping the pad off the board. Ooh, I need to be careful with that. There you go, it's fine. Oh, that was a bit of a capacitor. It's not actually part of the pad. That's good. Very quickly clean that with some flux. Hey, Kari. But I'm only at 300 degrees. Why too much heat? Okay, I will order some soldering paste next time. There we go. So, let me go get a fourth capacitor now. A fifth one, sorry. Oop. Okay. Well, that's good enough for me. Okay, there we go. Now to clean this bit off, we'll clean this section of the PCB. Okay, that should do for now. Let's put our new USB-C connector on. You learn to solder again? Yes, I am. I'm always learning to solder. I'm not a professional. Alright, so technically I should be done with that. Okay, so flux, flux, flux. That should be perfect. I had a long strip of solder I put somewhere and now I've misplaced. Oh well, I'll get another one. It'll probably turn up on my desk tomorrow. Right, let's try this. Ah, it's moving the pins around and I don't like that. Let me just quickly get some tape to secure one side of that connector down. Just so it can't slide. The problem is it can slide back and forth, and I don't want that to happen, so I'm just going to fix that down into place. I've done a terrible job at that. Okay, that should hopefully stop it from moving. Okay, there we go. the pins at the back now. Okay, so now if I plug this in, it shouldn't release the magic smoke. Okay, that seems good. So now we just need to put the LiDO in, and then it should power itself up once I solder these two legs first. I forgot to do that. Clean your tip with stainless wool. I don't have stainless wool, I've got this block brass stuff. You see there? There you go, now clean. Okay. So yeah, that's secure. Okay, now where's my LiDO? Linear voltage divider. Here it is, it came from Mouser, it's the special packet. Clean the two outer pins. Okay, I'll do that in a sec. I want to make sure the circuit works first. God. Wait, when you say the outer pins, you mean as in... Oh god, yeah. Okay, that's a good shout. There you go, that should be better now. You get solder wire with plumb bum 60SN 40p. Okay, look that up. Oh my god, these things are tiny. Should be done with you now. They are so adorable. Okay, well luckily because this I've got one pin on this side, I could probably solder first to align the thing. Yeah, so I could probably align him first on that one top corner pin. So let's quickly do that. And yes, I will tidy up that little bit which has just fallen off him. There we go. Little bit too far to the left. Nope, I've messed that up. Ah! I dropped him. I definitely need better tweezers. Also, your flux is shady, it evaporates really fast, so stay in more liquid state. Okay. get a better grip of this chip. Ah, that doesn't look great either. There we go. That looks a bit better now. You can trade on old PC components, something destroying for hardware if you have. I use it a lot. I make chip tuning for about 10 years. Okay, I might actually try that. Okay. I think we are done. With this circuit at least. Fingers crossed, indeed. Oh, bugger. These capacitors are so fragile. There we go. Right, where's to put all my capacitors? I need another one. There we go. By the way guys, I am now part of the car hacking Discord server. I joined literally after the stream last week because you guys encouraged me to. I was like, yeah sure, come join. So I am now there. Okay. So I think we are ready now to test. So I'm going to go to my combined view. Go to my combined view, and I'm going to open up a terminal, and I'm going to go watch N1 LS USB. Okay, let's see if something pops up when I plug this in. Okay, absolutely nothing happens. Well, that's a bummer. The chip isn't hot at all. Okay, time to bring out the oscilloscope. So I'm just going to connect this to PCB ground. Let's see if I can even do that. I think I can get away with just connecting this to the top of the USB-C connector. Is there anything on there which could short? Let me just quickly check. No. Actually, without the probe, it should just be able to give me a voltage reading, so... Okay, if I quickly do measure, all measure on. Okay, and zoom in on here. It's 2 volts per peak, and go across to this signal rail here. Okay, I'm seeing 3.8 volts, however it's really not stable. It's like bouncing everywhere. Oh wait, that's probably because I'm not grounded. Stupid me. Okay, let me, as a quick temporary thing, just solder a wire to PCB ground up there so that I can at least attach my probe to it. You changed the USB UART driver? Yes, I did. I'm now using a CP34, CP2104, which is the same hardware as Markina uses for their A0. So I was just like, hey, if they can do it and it works, then I'll probably use it as well. That was my logic behind using it. Okay. So we are connected to ground now, so let's quickly go ahead and connect my probe to ground. There we go. And plug it back in again, now measure the voltage. Huh, now we're only seeing 560 millivolts. What's the voltage on here? Nope. Max is 5.5 volts. I'm only seeing 560 millivolts on output. Why is that? Okay, let's quickly have a look at this driver here. What are you? You are this thing. Let's quickly go open, view the datasheet for this. View PDF. Ultra low noise, yep. 250 milliamp regulator, yep, okay. Operating input voltage from 2.2 to 5.5 volts. So my input voltage shouldn't be a problem, really. Oh, yeah, okay, so this pin here is the output pin. This pit here is not connected to anything. Then you have on the other side in, ground, and enable. So my question is, what is the enable pin connect? What should the enable be? Enable says on. Enable says, yeah, on should be high, according to this data sheet. So why am I not getting any power? Oh, this is beyond frustrating. I thought we'd fixed everything, but no. This PCB decides it's going to mess up again. So, on the enable pin, I currently have 5.52 volts. On the input pin, I have 5.5 volts. And on the ground pin, I have 0. That's correct. And then on the output pin of this, I have 500 milliamps. No, sorry, 500 millivolts, which is way not enough to power this. So I'm trying to work out why that is, though. Could it just be I'm using a bad cable? 1 second whilst I go get myself a better USB-C cable. Okay, I'm back. Right, so let's short in USB UART IC. Oh, that's a good point. It could be. Measure if you have a short on the output to ground. Okay, I'll do that in just a second. Just want to make sure first of all that I'm actually getting a stable voltage supply to the input. Okay, how about now? Let's quickly measure. Yeah, 560 millivolts. I mean, currently I see 320 millivolts when shorted to ground. So you might be very right, and I do have a short somewhere. It could just be because the chip isn't enabling it itself. Let's have a quick look here on the schematics. So, these 4 pins here should all be 3.3 input. So, and then there's the USB data line pins. Oh, I'm moving the wrong thing down. Whoops. Then there's the USB V bus, and then ground is at the bottom here. So let's quickly have a look here at this one. So ground seems to be okay. But I'm seeing 240 millivolts now on the ground pin of that IC. So that doesn't seem right at all. Next pin could be a dead cap. I mean, to be fair, it could probably be, or maybe I haven't connected one of the caps up properly. Maybe that's all it is. 320 millivolts here, 5.6 volts here, but the voltage is fluctuating really rapidly on this bit here. Should I take the cap out and then see what it says? Is that a sensible move, just to remove the cap entirely? Okay, let's remove the oscilloscope, let's remove the USB-C cable, and let's try that again. You don't need the caps. Okay, well let's try it without the caps then. So, do a bit of flux cleaning, and let's rip this, well not rip him, but you know, take him out the board. I'm just checking to see if I've actually hooked it up properly. Check for a short between IC plus and minus. Okay, 1 sec for me to go get my multimeter. Okay, I'm back with the multimeter, so just make sure these probes work. Yep, they do. So, let me just quickly check between this and this. This and this. There's a 1200 ohm resistance between ground and the top, but that could be the caps. So let's try between the IC ground pin and IC voltage. So put you on that pin, and I'll put you up there because that's the closest I can measure to that. Nope, infinite. It's not picking up anything. But let me just quickly do a sanity check here and make sure that I am able to pick that up by short. Yeah, okay, so that shorts. And these don't. Okay. So that's made me a little bit hopeful. Just remove the caps on the output line. Yeah, we can do. Wait 1 second, what does this guy do? Oh, also, wait 1 sec, I want to make sure that this cap is okay up here, so I should be seeing USB V bus on there. On that one pin. Let's quickly check. Then I have a short between this and this. Oh, and... oh, let me turn this guy on. So between this pin up here, oh, this one, and one of the other pins that you can't see. Yep, short. And from between here and the second pin. Yep, and from the first pin I shouldn't have anything. Great, okay. So USB V bus is okay. So yes, I think our next course of action is just to rip out all the caps up here and see how it then performs. So I need my tweezers for pulley. Oh, don't want to move the whole rig that I've got for my camera. There we go. Oh, I've knocked that badly out of focus. There we go. So... should just be able to come off. Okay. There we go. One's out. Let's see if that fixed the problem. I just want to see if we can locate the faulty cap, so I'm just going to keep doing trial and error. Okay, so it's not that cap, and what am I seeing on my oscilloscope? Has it improved anything, or has it gotten worse? I'm seeing 480 millivolts now, so it's gotten worse. Without that cap there. Okay, so let's try the next cap. Oh yeah, that did not feel like it was fixed into place. There we go. Again, I broke the cap slightly. So that goes that one. Actually, let's quickly just redo these two pads here. There we go. Okay, let's try now. Nothing. How about voltage? $480 millivolts. It's just as bad. Okay, let's try. I reckon it could be this one then. Okay, this one's proving to be difficult. Hey Alex. So we are currently, just to update Alex and anyone else who's recently joined, we're currently removing all the capacitors from the board because I'm not getting the correct voltage and we think we might have a dead cap. But now we're trying to work out which cap is the dead one. Okay, so let's try it without any caps on. Oh! Have I not even connected that pin? Oh, that pin there, the one in the corner, does not seem like it's connected properly. And that pin that's not connected properly is USB V bus. Wait, what pin actually is it? It is, if I can find it. It looks, it's the one opposite the output pin, yeah? It's the enable pin. Okay, so if that one isn't enabled properly, then I suppose that might be why we're getting such a low voltage. We can just quickly check that. Whilst the temperature of your iron seems to be too high because all the caps break in half. It's only set to 300. Okay, so we've given it a little bit more. And just redo all these joints just to make sure they're all okay. Okay, let's try it again then. Without any caps. Do you not have hot air station? No, I don't. Ooh, I'm seeing 4.7 volts now. Yay! Okay, I'm seeing 4.7 volts here. That's definitely good. It's not stable, but it's 4.7 volts. So I guess that cap was... Hey, look at that! Silicon Labs. CP210 UART controller. Yay! Okay, I'm happy about that. I'm very happy that it was just a dead cap. Or it could have been just bad joints. I can't tell what the problem was. Want to borrow mine? I don't need an ATM. Tank proof? I should be okay. I might actually get one. Myself. Do not reuse the old caps. Why would I? That's a... No, I would never do that. Okay, so I think what I'm going to do now is I'm going to plug in the caps one by one. Right? And see what works. And then when it stops working, I mean, I know that we've placed a bad cap in. And that I should probably remove it. Because it seems that a lot of these caps that I'm placing might be dead. Thank you LCSC Electronics for providing me with so many dud capacitors. Okay, so I need 1, 2, 3 caps here. I think he can't I can regulate it. What should I, if I can regulate it, what temperature should I set it to? I can go from 200 degrees to 450 degrees. Like 250 depending on what paste you're using? Okay, let's go down to 250 then. Let's go to 250 and see if this melts. If it doesn't melt, then I'll go back to 300. Okay. I know you guys can't see this, but this is just way easier for me to do. One sec. Just check that placement is absolute garbage. Yeah, that capacitor placement is not ideal. Make 20C lower. Okay, we'll do that now then. Left hand soldering for the win. Woo. Okay, that's better placement. Okay, so let's quickly check if this still comes up when I plug this in. Yep, I see CP210 UART bridge. Okay, just quickly checking a bunch of things that people are sending me right now. One sec. Okay, right, I'm back to here. You can place all the caps, the issue was the enable pin. Ah, okay. So I guess it was the enable pin then. Okay, so yeah, we'll go back to placing caps. Well, I mean, it could have been a cap. We don't know. Because I sorted the enable pin at the same time as doing that last capacitor. Which is a very stupid way of thinking of it methodology-wise. Okay. Give it some stable energy. I'm with Booham. Oh, hi Ash. Hi Ash. Not hi. Why am I saying that? Hi Lippy. I'm tired. Long day at work. Okay. Right, let's put this cap down. That needs a bit more solder. Last cap on the input and the voltage was okay. Okay, there we go. And I need my last cap. Where did he go? Okay, looks like I misplaced the last capacitor. Guess I'm taking another one. There we go. So you can go in that spot up here. So you can go like this. And I've completely reshuffled that cap, one sec. That's awful. Okay, you know what? We can sort out that cap later, but that seems to be good enough for now. So let me just plug this in and check how stable the voltage is. I'm curious to see on my oscilloscope how stable it now is, because it was varying wildly when we didn't have the caps in. So attach you to ground and attach you there. Oh wow, that's way better. However, we're only seeing, we're seeing 3.52 volts. Oh, that is like, so it's the oscilloscope is saying we have a deviation about 50 millivolts. So I'd reckon that's stable for now. Okay. So we are done with this circuit. So what's next in order to give power to the ESP32? I'm going to work my way that way up the PCB. So to now give power to that guy, we need C7. And we also need the reset circuit to be installed. And then I think we can attempt an upload to the ESP32 on here. And if that works, I'm going to be very, very happy. That'll be okay, 15 millivolts, yeah. Okay, cool. So, we need EN, so this is the enable circuit. So I need to put this capacitor on here, then a resistor, then another cap there. And then that should ensure that the voltage going to ESP32 backwards is stable. Come on. So we'll just do those for now. This circuit here I don't need to worry about because that's the voltage measuring circuit for the board that we can do last. And I'm just going to flux everything now that I know I need to complete the reset circuit. Definitely going to need this IC installed. And that cap. Okay, so let's start down here. So I have my resistors. Yep. Let me just make sure this guy's correct. I click on him. He says he is R4. If I go to, well, actually I'll go with my combined view. There we go. If we go to I/O, R4 is this boy up here, which should be C104595, C104595. Brilliant. Actually, let's do C5 and C6 first, since I know how much of a pain these capacitors are to solder. Let's get the hard ones out the way. Oh wait, what? How has it done that? I put solder on this pin and the solder ends up on that pin. Okay, that's bizarre, but you know, I guess sometimes it just does that. Let's clean up this pin though. Quickly want to grab my multimeter, make sure that there's no continuity between those two capacitor pins, even though it doesn't look like there is. Just want to be safe. Cool, there isn't. So I need 2 more of my caps. I shall get all 3 of them. I think that's it for these capacitors. Oh, there's one more for the CAN chip, but yeah. Have you solder wick? Yes, I do. I do have solder wick. I just hate using it. I seem to burn my hand whenever I try touching it. Which probably makes sense because it's copper. I'm gonna get a little bit more solder on that pin. You should get a fine tip. I think I do. I think I do. 1 second. Let me turn my soldering iron off and let's switch tips. When you say fine tip, what do you how fine are we talking? Like, would one of these ones do? These like needle nose ones? Would that work? Would that be good enough? GG better. Okay, cool. We'll roll with this one then. Just let me somehow find a way of opening my soldering iron without necessarily burning my hand off. I could use this cardboard as insulation. I swear I had something for this, for dealing with hot stuff. See if I can find it. 1 minute. Yeah, that soldering iron is extremely hot and I am not touching it. Put it to vertical quickly. To be fair, currently I'm just using my shirt as like a barrier. I've doubled up my shirt in that. Cut a little piece and use tweezers to pull it on the solid. Oh, that's clever. Okay. Actually, I think for this I can now use my tweezers. Okay, so soldering tip is back on. Oh, okay, I can use my tweezers to put the tip back on. That's really handy. And now I can turn my iron back on. Okay. New tip is installed. I'm just going to wait a couple of minutes, a minute or so for the soldering iron to warm back up, and then we'll get back to soldering. We can't wait. We can't wait, or we can wait. Was that a typo, or are you saying you literally want me to start soldering right now because you can't wait? Okay, tip is ready. Ah, it's stuck. There we go. Get out. Get off the tweezers. Stupid capacitor. I think it was a mistake for me to use this size capacitor with my level of soldering. Don't quite think I thought this through, to be fair. I should have probably ordered bigger components. Add a little temp. Okay. We shall do just that. Okay, so I'm now assuming those are ready, so we can add R14 in, which is, if I can find him, here he is. Plenty of room on your PCB, so try 1206 next time. Yeah, I'll try that. I think that should hopefully ease the pain. Actually, before I do anything, let me just quickly check that R4 and... Ooh. Quickly check that R4 and R1 are the same resistance. R4 is 10k, R1 is 10k. Cool, they are the same component. Actually, I guess 0402 given how big the 1206 footprint is. Oh, okay. Just tinning both pads of those. Okay, this capacitor goes up there because I need him in a bit. And I go find my tweezers now. Or better, use stencil in an oven for soldering SMD. Yeah, I might actually just do that next time, to be fair. But it's not as fun because I don't get to stream it. I mean, I could, but I have no way of streaming it. Is my problem. Oh, these are definitely way easier to solder. There we go. Or get a hot plate. Yeah, I think I just need to get better soldering equipment for this. Okay. So if these two in, I just have to do D9 before we can test the reset circuit. Make sure that works. If I can find D9, which is NPM 150 volt, 150 amp, 62892. Check the schematics. Q9 is UMH3N, and this is UMH3N. Okay, so let me quickly open this up, and then I'll flick the screen back to full view. Luckily with these, I managed to buy so many of them, because the minimum order was 10. Oop. So now I'm done with you, so you can go in that pile down there. Okay, so now the question is, on Q9, which orientation does this chip go? Okay, I think that corner down there is the dot. Please tell me otherwise. Go to my PCB view. Ah, the dot's in rotated round. So I have to bring... Yeah, so I have to bring you round like that to fit into place. Does your solder wire have flux in it? Yes, it does. Let me push this guy off here just for a sec so I can tin the wires. Cool. Double check with the data sheet. Okay, let me quickly do that. So let's quickly find him. You are a H3N, I see. Data sheet. Well, that's useful. There's no... So it says there should be a line on one of these. UMT6. No, this is not what I want. This isn't the IC I have. There's no line on it, there's just a dot. Huh. What package does this say? I can bring you up close to the camera just so we can have a good look. One sec, let's zoom in on him. Yeah, I don't see any band. Actually, can we just quickly... Oh yeah, that hasn't helped at all. Yeah, so this dot is definitely this way. Okay, so we're just going to quickly pop that leg on, and then we can... Oh yeah, it does have one with a... I'm just quickly looking at the data sheet on me. Yeah, it does have one with the line on it. Okay, that's useful. Okay, just quickly perfecting all these pins here. There we go. Now we're done up here, I can definitely tidy this bit up. Yes, whoever's idea was it to change the tip, thank you so much. Okay, so now I feel like we are ready just to put the last cap on down here, and then we can solder the ESP32 onto the board, and hope to dear God that it works. Okay, so I feel like we can try uploading, and I think if we try uploading at this point, I should see on the enable pin that the voltage drops to 0 volts when RTS is called, so we can quickly try that. So I'm gonna fire up the Arduino IDE. Just make sure there's nothing on here that I don't want you guys to see. Yeah, there isn't. Okay, so we shall go to the combine view, and we shall actually close that. And we shall do tools board, rover, 115200, 180 megahertz, partition scheme. Yeah, that's fine. Core debug level none. Port. Ooh, let's plug that in first. Okay, so we're currently plugged in. Tools, port, USB 0, cool. So now I'm going to grab the oscilloscope and I'm going to plop it onto the enable pin. We're currently seeing 3.4 volts. Oop, didn't want to jog that. Actually, God, well, there's a huge grounding connector here. Why didn't I just think of that? Yeah, let me just connect my wire back up to the ground port, because for some reason it disconnected itself. And I'm doing this off camera, I know. It won't stick, stupid thing. You know what? I'm just going to be lazy and use actually a bit of solder as my grounding connection. There we go. Okay, so if this goes well, when I hit upload, I should see on my oscilloscope the voltage suddenly drop. Let's give that a go. Oh, it did it! Okay, I saw it quickly go down. And now it's trying to connect. Okay, so I think now we try loading our ESP32 onto the board. Now that I know that works. So let's put this fat boy on. Let me find him. Here he is. My fantastic rover beam module. Actually, let's flux one pad and use the others for positioning. I'm going to do you. And all of you on this side I'm just going to use for now to keep the thing in place so it doesn't go walkies. Okay, I think that looks good. And actually I'm going to get some tape as well just to hold the ESP32 down on the board, because I really don't want that moving. Okay, that should be good. Okay, that pin's on. Let's do its opposite neighbour. Oh dear, we might have shorted these 2 pins out now. Oh god almighty, that is awful. However, I can take that off now. Definitely need to fix that. There is just one wire for ground, but I've designed that so it's large enough to hopefully do from the bottom side rather than from the top side. Check that, one sec. Zoom in. I think that's just about good. Okay, for some reason the soldering iron is getting stuck, so I'm just going to turn the heat up on it. I think it's getting sucked. The heat's getting sucked as soon as I touch the ground plane on the ESP. No, the wire... No, the big ground wire there is on purpose. There's a ground pad on the ESP, which it connects to. I made the wire that big just so I could solder it. Okay, so I think that's good enough for this side. Let's actually see if I can make the light a bit brighter just so you guys can see. There we go. Other side. More flux. One sec, I need my tiny bit of soldering wick. So, actually, I think I can fix it with flux rather than soldering wick. No, there's simply too much solder here, I need the wick. Okay, I'm going to try whoever suggested it to use tweezers to drag it across the board. One sec. There we go. Okay, so I think this ESP32 has been formally soldered. Let me just quickly check up close. No, there's a pin missing. Soldering wick took the solder out of this pin. There we go. Okay, so I suppose now, once I just quickly check this up close, so let's very quickly go like this, and just check all the pins. Okay, I'm happy with that side. Okay, I need to fix that one at the very end, but other than that I'm happy with this side as well. Let me very quickly just fix that. Okay, I'm happy with that. So now I suppose it's a moment of truth. Let's plug it in and see if it will flash or if it releases the blue smoke. Okay, it hasn't died. Let's go to combine view. ESP32 hasn't suddenly started getting very hot, which is good. Okay, let's upload. No such file or directory. Oh, because I must have unplugged it. Oh dear. Oh, because I haven't actually plugged it in. Okay, let's try that again. Oh, this isn't a good sign. It's just holding on waiting. Oh, what's going on? Crap, why is it doing this? Yeah, timeout waiting for packet header. Same error we had last time. Okay, time to bring in... Could it be a fault? Could I have faulty ESP32s? Or could... Oh, actually, let me unplug this. I wonder, could I have shorted pins round on this side, which is tampering with the serial connection? Let's just clean these up a bit more. Hi, Russian guy, I can't pronounce your name. Let me double check this. Okay. Okay, I think it's best if I get my multimeter and just make sure that there's no bridges from measure. Yeah, power pins for short. That's what I'm just about to do. So I'm basically going to take my multimeter and probe it to every pin that's next to its cell, next to its neighbor. Okay, there's definitely a short there. Whatever is between? Yeah, Vin and not Vin and ground. This is on the other side. This would be 28 and 29. However, they're not connected to anything. Where are you from, Ash? I'm from UK. I'm from England. Okay, tell you what. Let me change my tip again to that flat one because I think that lets me drag solder across a bit better than this one does. Oh, you're check, nice. Okay, so I'm trying to do this transplant my soldering iron tips whilst it's still hot, so do not recommend you do this. Okay, we're back up and running. Turn the tip back on and let's let that warm up. I'm going to put some more flux on just to see if that helps prevent shorts. That ground pin really does not look like it's connected. Oh boy, why is it always the Germans who invade the chat? Okay, let me actually get my cotton bud just cleaned round. It's okay, I'm just joking. To be fair, there was a lot of particulates in there, so let me just quickly check if there's shorts in between each one of the pins now. This may take a bit of time, so bear with me. And I'm completely out of view. so these two are shorted. Let's quickly fix that. Why are these two shorting? Actually, I'm going to need to now go really close. Oh, wow. Check out that fat soldering, guys. I think I know why it's shorting. Like, literally every pin is shorting with every pin. Oh, God. Logical question, is solder wick the solution to this problem? It seems literally every single pin is shorted to every single pin. That is hilarious, but also really upsetting. Use more flux. Bro, did you see how much flux I used? Fine. And drag outwards. Use a small piece of solder wick. Okay. So, solder wick. Yeah, more flux. Double on the flux. Fine, we shall double it. Also, when you say drag outwards, do you mean like this way? I'm dragging rather than this way. Rather than this way, I go from the pin this way. Your flux is low quality and even... I've got a second can of flux. Down. Okay, let's do that. So let's first of all go down. Yeah, that's revealed a lot of loose bits from IC out. Okay. Okay, now let's go IC out. IC out. Okay, let's quickly check this now. Oh, I'm going the wrong way. Tip. Okay, it's better now. Now all the bridges are on the front. Oh, you probably can't see that well. Yep, so now let's just do it again. You have too much solder. There's still a lot of bridges. Yeah, I know. Let's quickly check now. Okay, now we go IC down. better, but still bridging by the looks of it. Oh, Jesus Christ, you know why? That's a whole load of solder in there. I remember I was using an entire solder. Oh, I'm an idiot. One sec. So basically, I was an idiot and decided to use an entire... So I'm just going to be trying to melt this. Okay, let's try that now. Why can't I see that with my own eye? There seems to be this whole line of solder, which I can't see when I look up close. I'm so confused as to what that is. I guess time for the wick again. Well, yeah, it might be a reflection. Okay, well, let's try using some more wick to clean up this mess. Yeah, I'll try in just a sec. Ah, it's getting stuck. Okay, wait. Out you come. Okay, so let me quickly test these with the multimeter now, see if they short out. Where did my multimeter go? I have somehow managed to misplace something as large as a multimeter. Oh, it's right here on my desk. Silly me. Okay, so these two pins are okay. Yeah, that does short. Okay. 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 Okay, so now I need to resolder with less solder, because now we have literally no connection between the ESP and the components underneath. So I'm going to do that draggy thing with all these pins. Double down the flux.
Most people are creative in one way or the other. A lot of people feel like they have a book in them, or they have a song in them, or they have a TV show idea. And you can sit around and talk about that all you want. But until it is actually reality, it doesn't count.
Okay. So how do you recommend I solder this then?
I don't know how many songs I half wrote, but never quite finished, and never finished So it kind of doesn't count until you finish it and then put it out into the world. Now, I'm not saying put crap out into the world, but there comes a time when finishing and moving on, I think, is vital. Otherwise, you're just
Fine tip. Okay. Well, let's actually quickly sort out the other side, because the other side's also a complete mess, and then we'll do that. Then we'll do both sides with the fine tip. So, flux. Solder wick. Hang on, that's not working. This PCB's moving. Where's my tape? Okay, sorry if you can't see this, but yeah. I'm gonna have to do this with two hands, so I've got no hands to move the camera.
Otherwise, you're just the guy talking about your art. You're not the guy doing it. You get better by doing it, finishing it, learning from that process, and moving on to the next thing.
We'll just quickly do a continuity check on this side, and then if we can make sure that there are no contacts, then I will do just that. Actually, let me quickly clean this little area up around here. Okay, so now we do tip by tip. Soldering underneath the pins you can't really see, yeah. Now that I'm happy that nothing on this ESP is sort of shorting. Nope. Yep, okay, we're good. So now let's change tips and do bit by bit. Okay, so now I shall wait for this to warm up. and then we shall get back to soldering again with the finest solder I have. Okay, we're ready. Okay, maybe give it a couple more seconds, it's still being very cold. Just let some flux and reflow each pin. Okay. So I'm actually going to do it like this because then it's easier for me to hold the board. Okay, I think this side is okay now. Let's have a quick look. Up close. Oh wow, that is so much better than it was before. Okay, definitely no shorts there. Other side now. Hey, this side still looks like it's bridging. Okay, I'm gonna go with... Oh, actually, no, it does look a lot better. Okay, let's try uploading now. Once I just quickly clean this area up. Since there is so much flux on this side of the board. Okay. Let's try it now. Moment of truth, guys. Oh my god! It did it! I'm so happy. Oh my god, I'm actually so happy that's worked. Woo! Okay, so this is good. I'm actually so I'm over the moon right now that works. Okay, so let's finish the rest of the circuitry down here, like the reset button and voltage measuring circuit, and then let's move on to the rest of the PCB, which hopefully, apart from these capacitors here, has nothing of that puny size. Actually, you know what I'm going to do now? I'm just going to quickly solder the buzzer in, because then I can do some tests to make sure that the I/O is working by telling it to beep the speaker, just to make sure that we can do a sanity check that the PCB is alive. Okay, I'm actually so happy. Can it go more than 115 kilobits? Let's have a look. So if we go Tools, Upload Speed, let's try 921/600. Let's see if it likes that. Yep, 925 kilobits per second worked. Oh yes, this is faster than my Tinsy at uploading. Okay, right, I'm trying to find my speaker somewhere. It's one of these chips. And I also need... what else do I need? Okay, I need these. I've got a pile down here of all the parts I need for this assembly, but I've put them out in stages so that I don't have everything on my desk. Where the hell did my speakers go? Ah, here they are. Boop. Look how cute that thing is, it's adorable. So this is apparently 80 decibels at 5 volts, which is why I bought one which is exceptionally loud, because I'm going to be running it for 3.3 volts, so hopefully that way it won't deafen us in the process. So now I have to quickly ask myself which way is positive and which way is negative. Does it really matter what way is positive on a piezo speaker? It shouldn't, should it? Okay, so I think we might have contact there, so if I quickly put some scotch tape on the speaker. Nah, I'm gonna make it go full blast. Okay, so let's quickly see which one's PC speaker. PC speaker is... actually, I can quickly go here and have a look. PC speaker is pin number 25. No, it's not. It's pin number 23. Okay. Let's say pin mode 23, output, digital write 23 high, delay. I'm just going to keep doing this just to see if it beeps. Okay, upload that. And the Arduino IDE has just completely frozen. Well, that's useful. Oh, right, because it wants me to save it. Okay, I'll just quickly save it on my desktop. Go! Wait, is pin mode... let's try IO15. Like... Actually, I can quickly check if you're using the oscilloscope, can't I? I can check using the oscilloscope if it's registering a voltage on there. Ooh, look at me, clever me. And it just seems to be locked to high right now. Yeah, buzzer plus just seems to be locked to high voltage right now. What's the current rating of the speaker? I don't know. I'll check in a bit. You are definitely... Oh, is IO 15? Well, is IO 15 pinned at 23? Or is... So, let's just try calling it IO 15 and seeing if the Arduino IDE recognizes that pin number. No, it doesn't like that. So I guess we're going with 23 then. Oh, it's analog right. That's why. Analog right is not declared in the scope. I'm sure I called that function correctly. Yeah, I did. Yeah, that should be correct. Do I need to include some kind of header? Analog right was not declared in the scope. Okay, I'll try including the Arduino. Hash include Arduino.h. Nope, still doesn't like analog right. Why don't... Is it an analog pin? Pin 23 should be. Let's quickly do rover B pin out. Here you go. Here's the rover module. Open link in new tab. Here you go. Open image in new tab. Okay, so we have pin number 23. Oh, it's GPIO 15, I think is what I have to call it. I think I have to call it analog, GPIO 15. But yeah, it's an analog one. Yeah, ADC 2_3 is the pin. Okay, so it's just called GPIO 15. GPIO 15 not found. ADC's analog read. Oh, of course. Yeah, but I should still be able to make it beep, right? I should still be able to send a current to it to say, hey, can you turn this pin on, please? I should still be able to do that. ADCs, do it faster. I don't want to do it faster. I want to... Okay, let's just call this pin 23, sod it. Like some sort of PMW. No. I just want to purely get like an on-off on that pin so I can tell if it works or not. And for some reason we just seem to be seeing it being tied to high voltage. Yeah, I'm just seeing a constant voltage through it. Okay, let's just blank all this stuff out and see if it goes back to 0 volts. Upload that with nothing on it. Because then that might be implied there's a short somewhere on this PCB if this is stuck at 3.3 volts. Yeah. Okay. This is very interesting. So it seems to be stuck at 3.4 volts, this pin. Look at the board header file for pin def. So that seems to be stuck at 3.3 volts. And you are connected right next to the 5 volt enable line. So is the 5 volt enable line also stuck at 3.3 volts? No, you are at ground. Five volt enable. Actually, yeah, 5 volt enable. Not, I was testing the wrong one. Whoops. Yeah, you are stuck at ground. So why would that? Oh, could it be because it's shorted to one of the SPI lines? Let me just quickly check the pin next to it, which is SD1. Just quickly check that if it's shorted across. That might explain why. Unplug. So I want to go from the third pin, 1, 2, 3, check the fourth and fifth. Nope, there is no short there between the third and fourth pin. 2, 3 and 4. Or the fourth and fifth pin. Actually, let me just double check that on my big screen so I can actually see what I'm doing. So, this is clock, SD0, SD1, IO15, which is the one I'm looking for the speaker. Okay, I'll try 15 in a sec. And no short. No short. So then why is this pin giving me 3.3 volts? I don't understand that. Because surely if it should turn the pin off, right? If it's not being used. Okay, let's try 15 then. Upload that. Okay, so now let's see what that does. Yep, still stuck at 3.44 volts. I have no idea why that's doing that. Let's just quickly check this. So, this pin here is this line here, which goes up across, which goes up across. It's the top line on this, which, yeah, goes to the inside of that pin. But then there's no pins around here which could give it 3 point... let's just check the other I/O pins, why not? So, SD0 is currently registering 0 volts. No, sorry, that's clock. SD0 is 3.2 volts. SD1 is 0 volts. Then IO23, which is my pin, is 3.44 volts. Then 0. Yeah, digital right now. I mean, it might be floating or something. No, wait, what? I'm confused, Alex. Which chat? Because I am reading the actual chat. Unless not all my messages are coming through on the stream chat. That would be interesting. Try 15 instead of 23. Digital write 15 high. Yeah, I did that. If you look at the code here, it does say that. Digital write 15. Oh, but then I'm not setting the right pin. Oops. Let's try that again. Pin is still on 23. Yeah, that's an oopsies. Oh, you're right. Okay, that does work. Okay, so let's see how loud this is. Well, I mean, it doesn't seem to work. does this speaker have a polarity? There doesn't seem to be any polarity here, but there is a line on this side. So I'm going to quickly find the data sheet for this, and then we are going to have a look to see its polarity. You're not going to hear it at 1 hertz. Also, apparently all of ESP32's pins are PWM capable, I think. So it shouldn't be a problem. Might need to modulate some frequency. Yeah, good point. Check the current rating. Yeah, I'm going to check that in a sec. Okay, let me find the data sheet for this. Check it bounce using the oscilloscope. Okay, well what I'm gonna... Okay, so we'll try that then. We'll just try delay 1. And upload. So it should be 100 hertz, right? Oh yeah, I hear that. Cool. Okay, so it does work, but is it polarity sensitive or can I put it the other way? No, it doesn't matter. Yeah, okay, so TLDR, I think I need to have a louder speaker. Actually, I've got a speaker which came with my Arduino kit. Let me just quickly see if that fits the same hole. If it does, then we can, because I know that's a lot louder than my current speaker. Aha, I've got 2 of them. Let's try this. Oh, it fits. Okay, let's try this speaker. See if this guy fits. I'll see what this guy does. Just as loud. And how about the other one I've got? Even taller boy. Oh god, that's a lot louder and also a lot more awful. So basically the reason for this speaker is so that if you're in the car and the gearbox says, oh, there's an internal fault, you can hear the error. However, now upon listening to it, I don't quite know how noticeable this would be in the car. But yeah. Let's give this one a go. I don't know, do I want the one which... I don't know. Do I want, in this one, the stock speaker, which is meant to come with the PCB, the speaker which sounds exactly the same as the stock one except it's a bit taller, or do I want the one which sounds like a fire engine? Because this actually does sound like a fire engine horn. Which one shall I use? Yeah, I'll give you a quick demo again. So here's the stock sound. Wait one sec. Here's the stock sound. Right? And here's the fire engine one that I think sounds like a fire engine. Oh wait. There you go. Be aware not fry GPIO by 40 millivolts. Yeah, I should probably take that into account. Actually, let's do delay nanos. So let's get 1000 hertz now. Yeah, that doesn't work. Oh, because that'd be 10,000 hertz, not 1,000 hertz. Try that again. Sorry, I'm uploading stuff in the background, so you guys can't hear that, see that, sorry. I think I'll just go for the stock speaker for now. Oh wow, that's way louder. As soon as you increase that. Let's put this guy in. Let's very quickly do THT soldering. The only THT component on the PCB is this. Everything else is standard. There we go. All done. So the BP boy is now part of my PCB. There he is. Okay, so now that that's done, so now I think we can use the speaker. If we hear the annoying tone on boot up, we know that we know that ESP32 is working. Essentially, that's my logic behind including that. So let's go and put in. I'm trying to think what we should do first. Do I assemble one of the torque converter circuits to play with? Or do we put the massive connector back on? Or do we solder the OEM connector on the TCM? We'll do that last. Let's first of all get the power circuits up and running. So we've got 5 and 3.3 volts running to this. Let's do that first. And for these components, I will probably need the fatter tips from now on. Because all of these components... Oh, actually, first of all... Yeah, definitely gonna need the fatter tips now. Okay, so let's start work on the power circuits then for the 3 and 5.5 volt delivery system to the PCB. I just now need to go on my hands and knees and find these components. So I've got the inductors, I've got the capacitors, I've got the other set of capacitors somewhere here. Where are you? Okay, these are the 3 amp DC, that's the 5.5 volt one. Wait, don't I need a diode on this? Yes I do. What diode do I need for that? Going back to the schematics, what diode number is that for the CAN power sensors lines? Come on. You should be 507 is the part number I'm looking for you. So which diode has 507 in its name? Or should I say starts with 507, 507, looking for 507. Here we go. We got the diodes. Got the other capacitors I need for this. And now, for some really bizarre reason, I'm also now missing the 3.3 volt bits. Oh, where the hell did they go? They can't have gone far. Let me check this side of my pile of things I have. Nope, definitely this side. Oh. Oh, I'm an idiot. I think I might have found them. No, I haven't. Well, now I have to work out where I put the 3.3 volt. Well, I must have picked them up, just forgot about them. Must have. Nope. 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 Well, this is embarrassing. It appears I have lost some very important components, even though they were literally on my desk earlier today. Okay, let's just carry on soldering. I'm sure they will turn up. Things which typically happen with me is that I lose something, and then it just turns up when I wasn't expecting it. So caps can go there for now. More caps. Okay, here are the diodes, so let's put those in. Let's put D2 in first. I'm just pre-fluxing all the major components on here. Okay, so where do we start? Actually, what I'm going to do is I'm going to do a little bit on these two pins up here. So I've got ground and battery connectors I can play with. So I can plug it into my power supply essentially and just kind of play with it that way. So I can see what's going on. Okay, so ground, I'm going against convention and my 5 volt rail will be white. Why aren't you going on there? Okay, well we'll try this one first. Actually, wait, better idea. If I get the right cables, I don't even need that fancy stuff. Okay, I think we'll deal with the power supply and I've lost my main solder. There it is. My big fat solder. I need a lot of this stuff. Fill the hole with solder, then put the wire in it. Yeah, good point. Okay, that's the ground wire in. And now I need to find my suitable colour. Actually, why am I struggling? I've got like loads of wires here. Sometimes I'm really stupid. Okay, and we shall use blue for positive. Okay, so I should be able to now run wires to my breadboard setup I have. I'm just quickly running these wires now so that we don't have to play with that later. Okay, wires have been run. So, I mean that also means I can plug my my thingy-bobs in, my oscilloscope, to a common ground, so I can get that ready, because for the inevitable it doesn't work moment where I then have to probe it. Because that will happen. Knowing my track record at this point, that will definitely happen. I'm gonna get something and it doesn't work, and then we're gonna have to figure out for half an hour about a stupid mistake that I've made, which is actually very simple to rectify, but it stopped my progress about half an hour. There we go. Right. So, plug my oscilloscope into this. Actually, in case this is a bit dangerous, I'm going to unplug all my other ECUs from my bench setup, because I've actually got a load of ECUs plugged in on my desk for work, and I don't want those to get destroyed by my shenanigans. So I'm just going to unplug them. Okay, we are ready, I think. Let's put the diodes in. Crap, where did I put them? Capacitors. Wait a minute. Oh, here they are. Yeah, here's the 3.3 volt things that I lost, that I thought I'd lost, and I was trying to desperately find. They're there. All along. And there's the 5.0 volt ones. Here we go, here are the diodes. Okay, let's get back to soldering, shall we? Sorry about the brief distraction. So I think we should try the 5 volt rail first, because then if that blows up, then we know that it won't. Then we know that the 3.3 volt one will probably blow up the ESP32. So I feel like that's a fair way of tackling this. So that goes in my garbage pile now. Oh, we still have a fair few people online, guys. Thank you very much for staying tuned during this late night soldering sesh. Okay, that diode's in place. Oh, I'm not filming the right part of the PCB, whoops. Okay, now for the inductor. Okay, so more solder. Okay, get the big cap in. I think that's the big, yeah, the big cap. Because I've got two different capacitor sizes for this. And then, actually, do we put the LM5? I'm thinking. Yeah, let's put the LM5 in, because that should still work without these two caps in, I think. Or at least it should kind of work without them. So that's LM5. By the way, if this PCB works perfectly and I'm happy with quality testing it, then I shall be releasing the schematics for everyone to look at. And yeah. And then you guys can hopefully help me make a better PCB over time. If, say, for instance, we spot a bug with certain gearboxes, or whoever, whoever wants to help test, go help test. And whoever doesn't want to test, you don't have to test. I'm hopefully eventually of doing like making scripts to flash the ECU via USB or via CAN or via Wi-Fi, so that it's being very inclusive. Anyone can flash it if they so want to. Ooh, hello, that's not straight. Come on, get out. There you go. That's better. Okay, now for the ground tab. Okay, so that should be the input capacitor done. Oh, I'm not filming it. There we go. That should be the input cap done. Now let's do the output cap. It's the bigger boy. Where did I put the other capacitors? Here they are. Brilliant. There we go, there's the other side of the cap. Let's put this on. There we go. So now if I connect this up, it shouldn't show like 15 volts on the 5-volt pin that I'm looking for. So connect you up. Also, if I connect it backwards, let me just quickly do a sanity check that it should yep, it tells me there's a short circuit. That's great. Okay, so with our probe we go to the 5-volt line. And there we go, 5.44 volts. That is beautiful. So now I'm feeling a bit more confident about hooking up the 3.3 volt line. So let's do that now. So first of all, diode. Put Mr. Diode in. Diode, where are you? Here you are. Come on. Thank you. Diodes were sticking, that's very strange. Okay. So now we are finished with this diode. It can go in that pile down there on my desk where I have bits that I've finished with. Okay, there's the other diode. Okay, that's assembled. Now we do this boy. Get him in. Okay, that's in. Actually flow a bit more solder around the edges of these guys here. Don't know if that's going to help anything, but probably shouldn't hurt. There we go. Okay, so now for the 3.3 volt, yeah, LM2576 3.3 volt. So this is one that we used on my first ever assembly stream, and I ended up managing to take it out the board, so... Actually, scrap that, I'm not going to use this. It's not sitting straight. So I think we'll just get a new one. What's your goal for tonight? To get power working and to get one of the solenoid circuits working so that we can do some testing. And then the other 4 solenoid circuits are basically just repeats of the first one, so I can just do them by hand later. Here we go. I will clean that up. Okay, now for the ground tab. That should do for now. Okay, and then finally we just need one big cap, and then we're done. So hopefully when I turn it on, it should work. And we should hear annoying beeping noises. If we hear annoying beeping noises, that's fantastic. I know you guys can't see this, sorry. There we go. Okay, so if I plug this in now, fingers crossed, it works. Moment of truth. 3, 2, 1. Hey! Best of all, it still works, and I could probably try programming it now with that 3.3 volt supply going the other way. Just make sure this still works. Hey! So I can now basically guarantee that this works in the car. Okay, so there's one more. Okay, I'm just going to shut this beeping up. Delay. Sorry about the noise. I'm getting to fixing that right now. Come on. Oh, I could not open you. Oh yeah, of course I've just unplugged it. Shut up. There we go. Okay, so what I want to check now is that the 5 volt disable line works. So basically, the ESP32 has the ability to send a signal to this LM receiver here to tell it, hey, stop sending power to, say for instance, the gearbox sensors if it detects an overspeed condition. So we're going to just quickly check which pin that's on. That is on IO2. So at startup we have, how many volts do we have coming out? We have, with it doing nothing, we have 5.6 volts. So if I say pin mode 2 output and just say digital write to high, that should stop it from sending power. Well, hey! I mean, we're getting 1 volt rather than, you know, but that could just be a bad grounding, so I'm happy with that. Okay, unplug and shut up. Cool, so I guess we're nearly done. So I'm going to do the TCC solenoid circuit, purely because that's the one which I've got the solenoid for, so we can test with. So this is where the fun's going to... Oh, first of all we have to do solenoid power. We have to hook this guy up. Let's quickly hook him up. NPN Diodes D-Pack power distributor. Yep, that's the one. So basically, with the help of the ESP, I can shut down power to all the solenoids should I need to. And that's again another safety feature I've built into this controller, is it has the ability to shut all power off to the solenoids if there's the correct condition for it to do so. Say for instance it detected that shutting off one of the solenoid MOSFETs hasn't done anything and the solenoid is still drawing way too much power. It can then just shut power off to the whole gearbox. Which is interesting, because that's something Daimler hasn't done in their gearbox. However, it trips the code for it, but I don't think there's the circuitry there to do something like that. Let's go in from this side. There we go. So now also I need to check about the solenoid powers. So if I quickly go to my schematic again, what pin is 12 volt disabled? EN solenoids is IO18. So I think actually if I turn this on there should be no power going to the solenoids. We have a problem. There is now literally no power. Oh shoot. Oh no, it's okay. I've just killed it. Oh. So this pin here, which should go back to... Oh, that's so frustrating. This pin here, which is the enabled pin, is now sending 12 volts unintentionally to the ESP32. Yeah, that's likely killed it. Well, we had a good run. I actually want to Google that controller though. I'm curious as to why it would do that, because I think I looked it up and it shouldn't do that. It shouldn't send that much power down the enable pin. Oh, that's so frustrating. I got so close to finishing this. Yep, and the ESP32 is extremely hot to the touch, so yeah, that's killed it. So what components are you? You are this. If we go to LCSC Electronics. Oh. Here we are.
Goodbye.
So on the SOT package, we got pin 1. Where's pin 1? Where's the pin out? So it's pin 1 and 3 that I'm interested in. So come on, show me. Yes, so I've pin source is connected to, oh damn it, I think we've done this the wrong way around. One sec. Source is pin 3. So in my case, pin 3 is connected to the power, and pin 1 is... Yeah, so, okay. So, pin 1 is connected to the controller, pin 3 is connected to source, and pin 2 is connected to the drain. So, why is it sending 12 volts back through that? I have no clue. Oh, you know what? I might have just had a huge what's its moment. Let me just double check the power on it. Yeah, 12 volts on that pin for the solenoid. Oh, for God's sake. So why is it sending 12 volts to the input pin? I have absolutely no idea. Oh, there it tells me here. Okay, well let me just quickly see if the UART bridge is dead. If it's not dead, we should be okay. I can just resolder a new ESP because I've got a spare one. Yep, this is dead as well. We've just killed the whole board. great. Well, this utterly sucks, so I think I'll end the stream here because there's not really much we can do now. So, sorry about that. Yeah. I'll keep everyone posted on Twitter, but we're getting closer to finishing this board now. It's just this stupid thing up here didn't send 12 volts back to the controller. Just so frustrating. Alright, well, everyone have a good night. See ya.